Hello students, welcome to classroom teaching. Students, in last session we have seen about the heating effect of electric current. Also in previous standards we learned about magnets, magnetism and also the magnetic field. Also we learned about electricity also. But think whether there is a connection, whether there is any relation between electricity and magnetism. It is very interesting to know the relation between them. Actually, many scientists, they tried to find out the relation between those magnetism and electricity. Oersted, he was the first scientist who performed an experiment for that. Actually, it was a very simple experiment. You can easily perform this experiment at home. For that you require only few things. First thing, you require a battery. You require a conducting wire. For that you require a key and a rheostat. Only these things we require. Rheostat, if you don't have rheostat, doesn't matter. You can change the current, you can change the amount of current by changing the cells in the battery, number of cells in the battery. Because rheostat is used only to change the electric current. As soon as we close the key, you can see in this video, the current starts flowing through the conductor, through the thick copper wire, and you can easily see the deflection in the magnetic needle. So why the deflection is there? Let us perform or let us understand this phenomenon with the help of circuit diagrams which are given in the notebook, which are given in the book. You can see the circuit diagrams here. A magnetic needle is placed and a conducting wire is there. As soon as we start the current flowing through the conductor, whenever the current flows through the conductor, we can see the deflection in the magnetic needle. Notice the direction of the deflection of the magnetic needle. Now, just by changing the positive and negative terminals, you can change the direction of electric current flowing through the conductor. Now change the direction of current flowing through the conductor and again observe the deflection in the magnetic needle. You can definitely see the magnetic needle, it deflects but in opposite direction. So why, first question, why there is a deflection in the magnetic needle? Students, we know that the magnetic needle, it gets deflected only if it is placed or it is in the magnetic field of any other magnet. Then only there is a deflection. So what is the meaning of that? Definitely it is placed in the magnetic field of any other magnet, but no magnet is there nearby. And we can see the deflection only when the current flows through the circuit or only when the current flows through the conductor. Whenever we open the key, current stops flowing and again magnetic needle comes into the north-south direction. That means it comes to the rest position. The meaning of that is, whenever current flows through the conductor, a magnetic field is created around that conductor. And this is the relation between electricity and magnetism. Whenever electric current flows through the conductor, we get a deflection. That means magnetic field is created, magnetic field is generated around that current carrying conductor. So let us discuss how the magnetic field is. That means what is the nature of that magnetic field, how the magnetic field lines are there, and what is how strong the magnetic field is, or on which things the magnetic field depends. Let us perform another experiment. You can see the diagram here. That means this diagram you can see, this is the diagram which is present in book also. What we are doing? Take a cardboard, make a hole in the cardboard, take a thick copper wire and pass it through the hole and complete the circuit. Make the circuit. Make the circuit means again connect that copper wire to rheostat, again to the battery and the key. As soon as we close the key, the current, it flows from positive terminal to negative terminal. That means it is in the downward direction. Before that, sprinkle some iron fillings around it. Or you can perform the same experiment to see the magnetic field lines, or to draw the magnetic field lines by using magnetic needle also. Place the magnetic needle at different positions here and note the direction whenever the current flows through the circuit, through the wire. Note the deflection in the magnetic needle and point it. You get the circles. Or simply if you sprinkle some iron fillings around it, and if the current passes through the conductor, gently tap that cardboard and you can see that all the iron fillings, they arrange themselves in a particular pattern, in a circular pattern around that wire. These circles where the iron fillings they stick, these are nothing but field lines. Magnetic field lines are there. That means between these two lines, if they are present, between the gap of that two lines, there is no magnetic field. Magnetic field is present only on these lines. Look, in this way you can get concentric circles where the iron fillings they stick. Within this area there is no iron filling. The iron filling sticks over these circles only. And most important thing, and these iron fillings where they stick, here the magnetic field lines are present. So as if we increase the current flowing through the circuit, I am not completing here the circuit. Okay, let us complete the circuit here. It is rheostat, or we can call it as variable resistance. Then if we take a battery here and a key. So here a positive terminal, it is a negative terminal, so current definitely flows in the downward direction. As soon as the current starts flowing, and if we gently tap the cardboard, iron fillings they stick over these circular lines. These are nothing but magnetic field lines. What happens if we increase the current flowing through the circuit? We can increase the current by changing the rheostat value. That means by changing the resistance value. It is variable resistance. So if we increase the current flowing through the circuit, then we get these lines to the larger distance. So definitely the strength of magnetic field it increases if we increase the current flowing through the wire. One more thing, if we go away from this wire, then the distance between these lines it also increases. We call it as rarefies. That means the rare lines we are getting, the next line if we get here, then it is at larger distance. So the distance also increases. That means the magnetic field, the strength of magnetic field, it reduces as we go away from the conductor. So what is about the direction of magnetic field now? The direction of magnetic field, it is given by right hand thumb rule. So it is nothing but Fleming's right hand thumb rule, and in this right hand thumb rule we can easily find out the direction of the magnetic field. So how? Imagine that you are holding a current carrying conductor in your hand, in your right hand, in such a way that the thumb it is stretched and all other fingers they are curled around the conductor. In this way, if thumb shows the direction of electric current, then this curled fingers gives the direction of magnetic field. In this way, if the current it is in upward direction, the magnetic field lines, the direction is this. But if the current it is in this direction, then downward direction, thumb shows the direction of electric current, then the curled fingers gives the direction of magnetic field. So the magnetic field lines in this case, these are in this way, because the current it is in downward direction. So what should be the direction of magnetic field if the current is flowing in the right direction, in this direction suppose? So stretch the thumb in this direction, you can get the direction of magnetic field. So direction of magnetic field, it is from down to up in this way. If we change the direction of current opposite, magnetic field direction also reverses. So we can get the direction of magnetic field by using right hand thumb rule, and this right hand thumb rule, it is also called as Maxwell's corkscrew rule. So this is about the relation between electricity and magnetism. That means when there is definitely there is a relation between them, and it is more interesting to know how electricity is generated by using magnetism, because there is a relation between them. In this case, we discuss only about whenever the current flows through the conductor, magnetic field is generated around that current carrying conductor. So we will stop here for this video. In next video, we will discuss about the magnetic field created by the current carrying conductor in a circular loop. So let us discuss it in next session. Thank you very much.